Hello, welcome to section 3.4, where we're going to graph linear inequalities in two variables. So basically, think of it this way. We're going to draw lines, and instead of just doing a single line, we're going to let that line is going to cut the plane into two pieces, and we're going to shade either side of the plane. So what is a linear inequality? Okay, so you have an inequality this here, that's like a line. Okay, it can be either greater than or equal to, less than or equal to, where A and B are not both zero. Okay, so we know that what is a solution of a linear inequality? Linear inequality. If all the points in that region fulfill the inequality. So what the heck am I talking about? So here, let's say for instance, here we have y is greater than x plus 4, okay? So when you're talking about solutions to this inequality, we're saying, okay, what are all possible points on the plane that satisfy this inequality? So let's see, for instance, here 0, 0. So this is x and y, right? We know that. So the question is 0 greater than 0 plus 4? So is 0 greater than 4? Not today. So no. Okay, so this is a no. So that's not a solution. Not solution. Okay. And how about B? So again, we just plug it in. So we have 6. Is 6 greater than 1 plus 4? 6 is greater than 5. Yes, it is. So yes, it's a solution. Okay, then let's go ahead and do the next one. C. 6 greater than 2 plus 4. So we have, is 6 greater than 6? No, it's exactly the same. So it's not greater than. So not a solution. Okay. Next, we have negative 15. Is that greater than negative 5 plus 4? So we have, is negative 15 greater than negative 1? And that's a no, because you know negative 15 is less than 1. So if it was over here, negative 1 would be like, over there. Okay, so no, not a solution. And then finally, E, we have 12 greater than negative 8 plus 4. So is 12 greater than negative 4? Yes. So this is definitely a solution. Okay. All right. Let's talk a little bit about the boundary line. So the line with if it was an equation, that would be the boundary line, okay, that separates the two regions, right? So remember, when we are graphing with one variable, you either have a parenthesis or a bracket, or like how I like to do, it's either open circle or closed circle, same thing. So similarly, if you have an inequality here, a linear inequality, but you see how it's strictly greater or strictly less, then we would have a dashed line. That means you don't include the line. But if it's an equal to, greater than or equal to, less than or equal to, or greater than or equal to, you would draw your line solidly. Okay. So let's look at this example. So let's say here we have the inequality y greater than x plus 4. Now the line itself is here, but because this is a strict inequality, it's dashed, okay? Now we want to know which ones are to the left or to the right. So 0, 0 doesn't fit. Negative 15 doesn't fit. But all these points here do fulfill the inequality, okay? Everything here. All right, let's look at another example. Here we have y is equal to 2x minus 1, okay? And we want to know what if I'm going to do less than or equal to or greater than or equal to. So if you have the point 0, 0, how is 0 compared to 2 times 0 minus 1? 0 is definitely, I know that it's part of the solution. It has to be greater than negative 1. But we include the boundary line, so it's greater than or equal to. So your inequality is y is greater than or equal to 2x minus 1. Okay. So how to graph it? Let's say we're just given the equation. So first of all, we need to know if it's, we need to identify the boundary line and graph it. And if it's a equality that contains the equal sign, it's solid. If it's a strict inequality, meaning no line, then it's dashed. Then we just we choose a test point, okay, and see if it's true or false. If it's true, we shade the side that includes the test point. If it's false, we shade the opposite side. Okay, so let's do a problem. Okay, so let's say here we have y is less than or equal to 2/3 x minus 5. So the boundary line is going to be y equals 2/3 x minus 5. Okay, fine. Let's go ahead and draw that. We have here, you know, 4, sorry. Okay. All right, that's good enough. So what's my b is -5 and my m is 2/3. So my starting point is right here, -5 or 5. That's my starting point. Then my slope is 2/3. So I'm going to go up 2 over 3, here, up 2 and then over 3, then up 2 and then over 1, 2, 3 here. Okay, something like that. Um, So then, is it solid or dashed? Okay, so let's look at there's a line here. Okay, so that means that the boundary line is a solid. Now, how do I know what side to fill? How do I choose the side to fill out? Okay, I need to choose what's called a test point. And usually the test point, the easiest one is the origin. See how the origin's over here? Origin, okay, and that's the point 0, 0. And we're going to plug it into this inequality here and see if it's true or false. So we have 0. The question is 0 less than or equal to 2/3 times 0 minus 5? So is 0 less than or equal to -5? No, it's not. So this is false. So what that means is, hey, we don't include this side. We need to shade the other side, okay? The side that did not include the test point. Okay, so that's it. And that's our drawing here. And I just like coloring with this. It's so pretty. Okay, all right, let's do another one. Y is less than or equal to 4x. Okay, so this is a line that actually starts at the origin because there's no zero, there's no when you do not see the y-intercept, it's 0. If it's in the form y equal mx plus b. So in this case, y is equal to -4x would be our boundary line. So it starts at 0 and then it goes, the slope is -4 over 1. So it would be down 4 to the right 1, 1, 2, 3, 4, right, like that. Okay. So starting from here, down 4, and then over 1, down 4, 3, 4, and then over 1, okay? Like that. And then is it solid or dashed? It's solid. Okay, so we draw the line. Solid. Now, what side do we shade? Well, we can't use the we can't use the origin as a test point because the origin is being used in the boundary line, so we can't use that. Let's pick something easy. Let's pick how about this point here, 1, 1. That could be our test point. So if we pick 1, 1, we're basically saying, okay, well, is 1 less than or equal to -4 times 1? So is 1 less than or equal to -4? No, that's false. Okay, so that means we shade the other side that does not include the test point. Okay, if it had been true, we would shade the side that includes the test point. Okay, all right. So we shade the other side here. This side right here. I know, everyone's in awe. Okay, all right, one more. Let's see here. Well, let's do this one here. Okay, so let's graph the linear inequality. Y is greater than 3. Well, that's not hard at all because you have here, what's the boundary line? The boundary line is y equals 3. So that's just here. But it's not solid, so it's a dashed line because there's no equality, right? So this is the boundary line right here. Y is equal to 3. That's the boundary line, but it's dashed. And everything greater than that. So you can pick, if you had to pick the origin, for instance, you're going to get, is 0 greater than 3? No. Okay. But what if we pick this point here? Let's pick this point 0, 4. It doesn't matter what x is because the formula is y greater than 3. So this value of y is 4. So is 4 greater than 3? Yes. Okay, so we would pick the side that includes that. So we would graph up. See, these are all the values in the plane where y is greater than 3, and that makes sense. You pick any point in this region, and the y coordinate is going to be greater than 3. Okay? Of course, we do not include the boundary here. Okay? All right. And that is it for this section. Good luck. Super fun homework. Good luck. Happy studying, and I will see you in the next video.